All right, so I'm updating this form here will be listed as 23 fall. So I'm hoping that will eliminate some of the things that are extra in here. I'm also going to introduce to you a new type of reconstitution question that you probably won't see it this semester. I'm not anticipating you seeing it this semester, but you might see it in fourth semester. So I just wanted to present it to you so that way you have it. But let me go ahead and get down to some of these questions that have to do with heparin and insulin. And then we'll do the big heparin protocol. And what I'm going to do is to keep this fresh, I'm actually going to change some of the values here and see, that way we can have some different type of questions. Sorry, I had to do this before. Okay. All right. So one of the things that's kind of new with your infusions are the heparin and insulin type questions. So I think it just said on the blueprint just two. Let's double check. Yeah, there's two like heparin bolus, heparin infusion questions and two insulin questions. So I've actually written up more than that for your practice. You may or may not like that, but there's more. There's more than two. So I gave you a variety. That way you can kind of see what they look like. Let me just see something here. I'm just going to change a couple things here. I'm going to make this 500 units per hour. And then it's fine. Okay. So I don't like to change these too much because then it can get into some convoluted territory. Oh, and before I start, as always, I am recording these sessions. I will upload these to YouTube either later today or tomorrow. And then if you have questions, just type them into the chat or just unmute yourself. Some of these things should look familiar with what I'm going to show you. But I'm going to show you a strategy because these questions are a little bit different. Basically, all you're doing is converting one flow rate to another flow rate. The current flow rate is 500 units per hour. The new flow rate that they're looking for is milliliters per hour. So there's a couple ways you can answer this question, but I'm going to start off with what I think is the straightforward way, and then just piggybacking what I just said, we're doing one flow rate and we're converting it to another flow rate. What I mean, we're converting units per hour to milliliters per hour. Okay. And we're doing that for all these things that I'm going to show you here, whether it's heparin or insulin, that's all we're doing, was we're converting units to hours to milliliters per hour. Sometimes, and I've heard that students have told me that they had to convert milliliters to hour to unit per hour. You would just do the same thing, just you would just do it in a different you would just do it in the reverse order. I haven't yet found a good example of where you would do that, but it can be done. So, and I'll try and give you an example of that here in a moment. So let's say for this question, it says units per hour, which is 500 units per hour, and I want to convert it to milliliters per hour, but there's a step in between. And the step in between is I have to keep in mind what is my available. And in this instance, my available is a liter of IV that has 25,000 units in it. So that is my available, okay? So what I'm going to do is I'm going to set up a problem here, or set up a situation here where I'm going to take 500 units per hour. And what I'm going to do is I'm doing is I'm trying to convert units to milliliters. Okay. That's why I'm starting with the flow rate. That's what I chose to start with. If you're wondering like what's the magic, like it's up to you. I mean, if you want to start with milliliters, and 1,000 milliliters, 25,000 units is perfectly fine. Just make sure your orientation is correct. I start with the flow rate because I'm going from flow rate to a new flow rate, and that's just what I decided to do. What am I trying to do here is I'm trying to get rid of units and I'm trying to convert it to milliliters, and my available IV is what's going to allow me to do that. So having 1,000 milliliters, 25,000 units, that's what's going to allow me to convert units per hour to milliliters per hour. You can see before I do any kind of calculation, I'm pretty much done. I just got to plug it into my calculator. So saying that, calculator, 500 times 1,000, it's going to give me 500,000 divided by 25,000, and that's going to come out to 20 milliliters per hour. Now let's say I had a question that was similar, but it was asking me this in the reverse. So let me see if I can do that. So give me 1 second. So what I'm doing is I'm adding a different question. I'm going to use the same 0.45% normal saline. I'm going to use the same 1,000 milliliter IV heparin, 25,000 units. But instead, now I'm going to say it's 50 milliliters. Actually, let's make it interesting. Let's make it 125. Okay. So what I did is I changed this. Yeah. So if you're asking about where this is, so this isn't, this is in the same folder that all the practice test questions are located, which is in the OneDrive folder. So in the email you got, it says click here for practice tests. Click there, and it's in the Allegheny folder, and then the 220, 230, and you'll find this. And then this is being updated as we speak, so it won't be completely ready to go until after I'm done, but that's where it'll be. All right, so this is just a variation of the same type of question, but we're going to do it in reverse, where instead of looking for milliliters per hour, you're looking for units per hour. I don't know if you're going to get a question like this, but last semester I had a few people ask me about a question like this. I couldn't find any good examples, which means you have to kind of make it up. And so that's what I just did. So let me show you how I would set up this problem. And again, what are we doing? We're going from one type of flow rate, milliliters per hour, to another type of flow rate, units per hour. And so let's do that. So my initial flow rate in this example is 125 milliliters per hour. I have my same insulin IV bag available to me, the 1,000 milliliters and heparin 25,000 units. But in this instance, I'm looking for units per hour, not milliliters per hour. So I want to get rid of milliliters and I want to keep or convert to units. So you'll notice that I'm going to put 25,000 on the top this time and 1,000 on the bottom this time, because we're inverting the relationship based off of where we're starting and where we're going. And as always, if you remember, a lot of you have been working with me now for a couple years, you know that I do this mainly to show you that we're eliminating units, so that way we're left with what we're looking for. And unfortunately, the term units applies to everything, but then one of the units is called units. And what are we looking for? We're looking for units per hour. So we're converting milliliters per hour to units per hour. So I'm going to take my calculator, 125 times 25,000. I'm going to get 3,125,000. I'm going to divide by 1,000, and I'm going to get a number that is 3,125 units per hour. Okay. So if you ever get asked to convert milliliters out of units per hour, now you'll know how to do that. I don't think you're going to get asked that question, but it was, I wanted to at least do that. Oh, you look at that. I even had it down here. I didn't realize I already did that. Or did I copy that twice? That was weird. Okay, maybe I did already have that there. Sorry about that. Oh, we actually did that a couple times. Okay, that was my bad. I did this a couple times. Didn't realize I did that. So this is just another variation. I didn't realize that we did that. So sorry about that. Apparently repeating myself here, and I didn't even know that I did that. So, all right. Go ahead and work on this one. Type in your answer in the chat once you get it. I just want to make sure that you're getting this down. All right. So I'm seeing a lot of answers with 2,000 units. So let's see if that's the same thing I got. So I'm going to take 20 times 25,000 divided by 250. And I think we're all getting 2,000 units per hour. Good. Very good. All right. So the insulin flow rates are going to work exactly the same way. Okay. You're going to set it up exactly the same way. So you have your IV is 500 milliliters with 500 units. It's infusing at 10 units per hour. You're going to convert that to milliliters per hour. It's going to be the exact same setup for heparin. The only difference between these two questions, or the insulin infusions versus the heparin infusions, is that one's called insulin and one's called heparin. Otherwise, they're exactly the same calculation. All right, so let's move on to this monstrosity. And let me see if I can add some clarification on some of this stuff. And then we'll change some of the numbers here too, just so you know. All this writing here was just as a reminder for me to tell you what to do with these things. So you're seeing all these colors. I'm going to redo it, but I'm going to change up the question a little bit. So if you've watched my reviews before, you'll know that you'll sit there and go like, oh, it sounds like you're saying the same thing. And if you think that's bad, that's exactly how I feel. I'm like, I said this already. All right. So this series of questions, now that I'm changing all this, the key is going to change up a little bit, just so you know. you come back and you're like, why is the key different? Well, the key's different because I changed all the changed a lot of the things here. So let's make this someone is 176 pounds. Okay. So the heparin protocol, first and foremost, what you need to know is when we say heparin protocol, and this is my fault, like the way I should have introduced this, I should have made sure I accounted for some things. Like I should have underlined this or made that bold. I should have put a box around this, basically indicating that this is the heparin protocol. Like you would see it as like a poster somewhere in the room in the heparin unit or the heparin ward or whatever. I know it's more like cardiac. This is for preventing clots, but it would be posted somewhere to indicate this is the protocol, what we're following. Okay. So the protocol just tells you a couple of things, but you don't need to answer the questions that are stated in the protocol. They're just there to tell you where this information is coming from and that it's following a protocol. So if you do a Google search for heparin protocol, you're going to see standard weight-based heparin protocol. It'll be listed just like I listed it here. It's just that it might be listed as like I said, it'll look more like a table as opposed to, oh, I got to answer all these questions. When it comes to answering questions, it's just what's listed down below. Answer the following questions. Okay. So on the practice question sets that I gave you guys, I gave you 4 questions, A, B, C1, and C2. Okay. I gave you 4 series of questions to answer. On your actual test, you're only going to be answering 2 of the questions. You'll either answer A, B, or you'll answer C1, C2. That's it. And even though there's 2 questions there, it'll still only count as 1 question. But if you can do all 4, you're going to be more than prepared for the heparin bolus dose weight-based question. Okay. You will also see a pretty standard setup where it'll tell you to bolus the patient with the heparin 80 units per kilogram body weight, and then to start a drip at 18 units per kilogram per hour. You'll actually see that repeated in the protocol. Oops. Where it says bolus with 80 units per kilogram, start a drip at 80 units per kilogram per hour. We're just extrapolating some of the things. So I've also seen this question written as, here's your order, here's your available, which is what's listed here in number 2, and then patient's weight, and then it just asks the questions. So I think that's an easier way to do heparin. I unfortunately made it more difficult, but hopefully that helps you kind of see what this looks like and helps you to navigate through the information. This is the first time you're seeing it, so as far as you know, this is how it always looks. All right. So with the heparin bolus question, the main focus is answering these questions listed down below. So I've highlighted them in green and in blue relative to what it is that we're referencing. So the first question is, calculate the number of milliliters to administer for the bolus dose. So I have to do some work before I can get to my bolus dose. So the work I have to do is, first of all, what is my bolus? My bolus is 80 units per kilogram body weight. So before I do anything, I have to account for the patient's weight. I have to convert pounds to kilograms. So I think you already know you're going to take 176 pounds divided by 2.2, and you're going to get a patient weight of 80 kilograms. Right? So 176 divided by 2.2 is 80. Now, what if you get something like, oh, it's 84.5 or, 84.545454. It's a repeating number. I would suggest rounding to the nearest 10th. At that point, it should not be a problem for these heparin-based protocol problems. But always listen, whatever your lab instructor tells you to do. If they tell you to wait to round at the end, then you just wait to round at the end. Okay. All right. So we have the patient's weight and we know the order, which is 80 units per kilogram body weight. So let's go back down here. And I apologize, I'm going to bounce around here, which is a little bit frustrating. And what I'm going to do is I'm going to take the patient's weight in kilograms, and I'm going to multiply by the bolus dose order, which is the 80 units per kilogram. So this will look familiar. You've done this before in previous tests where when you're doing a weight-based calculation, you just take the patient's weight in kilograms, multiply it by sometimes it's milligrams per kilograms, and then that gives you the milligrams. You're going to do this a lot for those of you start doing your pediatrics. You're going to have another dosage calc test essentially during the semester for pediatrics. And it'll be a lot of weight-based calculations because obviously that's what's important for little kids, right? So 80 times 80 is going to give me 6,400 units. Now, if it was just asking for how many units to administer, we'd be done. But unfortunately, it doesn't ask that. It asks to calculate the number of milliliters. So you need to figure out your available. Well, I mentioned that this protocol tells you your availables, and that's actually what step 2 of the protocol, or procedure 2, or whatever it's called, this is what you have available. Okay, is heparin 25,000 units and 250 milliliters, half normal saline. And then it says bolus dosage strength, 1,000 units per milliliter. So there's 2 available. Okay. There's the IV that's sitting next or is connected to the patient already. And then if I want to give them a bolus dose, I have a separate syringe sitting off to the side ready to administer depending on what the protocol states. So bolus dose strength, 1,000 units per milliliter. What are we calculating? Bolus dose. So I'm going to take my 6,400 units and I'm going to convert the units or get rid of units for milliliters. And what did we say? 1,000 units per milliliter. So my bolus dose to get things started for my 176-pound patient is going to be 6.4 milliliters. Are there any questions on where I got 6.4 milliliters? Okay, thank you for your answer. Okay, good. Next thing. The next thing it says is to calculate the infusion rate. So again, we have to kind of look at the beginning of the problem or look at the actual protocol. We already did the bolus part, right? 80 units per kilogram. We're done with that. The next thing is to start a drip or start an infusion or start a flow rate at 18 units per kilogram per hour. Okay. So same patient. Patient's weight's the same. So I'm going to take 80 kilograms. This time I'm going to multiply it by my 18 units per kilogram per hour. $80 times 18 gives me 1,440 units per hour. Now this should look familiar, right? We have units per hour, but we're going to milliliters per hour. So I'm converting flow rate to flow rate. So you've already done this problem before. The only thing that might be different is the actual available. So what is my available? Well, looking at the heparin protocol, it says I have available heparin 25,000 units in 250 milliliters half normal saline. So I'm going to take that information. I'm going to get rid of units. And I'm going to convert it to milliliters. 250 milliliters, 25,000 units. We got rid of units. And then we should get, I think it's 14.4 milliliters per hour. That's supposed to be a 4. There we go. All right. So those are the two things that you're doing. Once you see it done, or at least once you've done it a couple times, it shouldn't be difficult math-wise. The tricky part is just figuring out, like, well, what am I supposed to do? So if you're sitting there thinking that, you're not alone when that comes to that. Okay. So though that's most likely you're going to get on your test, you're going to get like that part A, that part B, calculate the bolus, the initial bolus, calculate the initial infusion rate, and then that'll most likely be what you see. But I gave you some other examples just in case you do see another setup, and that way you know kind of what to do from there. But the other scenario is it might tell you that the person's already on a heparin infusion, and then after 6 hours, they recalculate the APTT. They see that it's 43 seconds, and they're going to ask you to do some more follow-up. So that's where this boxed in section comes in. It says you're going to look at the APTT and you're going to reevaluate, okay? And you're going to reassess. What do we do? So you're going to look and see each of these things. So like if it's less than 35 seconds, then you're going to rebolus with 80 units and then increase the rate to 4 units per kilogram per hour. So that's what you would do. So if it gave you like the APTT was 30 seconds, okay, they're still clotting too frequently. We got to change, we got to intervene. If it's between 36 and 44 seconds, which is the example I gave you, then we're going to rebolus again with 40 units per kilogram and then also increase the infusion rate. If they have a clotting time of 45 to 75 seconds in that range, you wouldn't do anything different. However, if that's the first question you get asked, you're still going to have to do the initial calculation, right? But technically, if it said like what would be the bolus dose, you would say 0 because you're not giving them another bolus. You would just continue the infusion rate as it's set. So that might be like in the example, it was 14.4 milliliters per hour. It would just continue at that infusion. If it's the clotting time is 76 to 90 seconds, it's taking too long for them to clot it. So now they're a risk of bleeding, right? So we're going to decrease the rate by 2 units per kilogram per hour. And then if it ends up being greater than 90 seconds, then you're going to hold for an hour, decrease the rate by 3 units per kilogram per hour, and then reassess again. So just that's how you navigate the quote unquote heparin protocol. I'm sorry that I wrote it like this, but hopefully that's not too bad. Oh, okay. Yep. You're welcome. All right. So for the 43 seconds, it told us to rebolus, right? Rebolus with 40 units. So I'm going to take the same patient, right? Didn't change patients, same weight. But this time, instead of 40 units per kilogram or 80 units per kilogram, now it's going to be 40 units per kilogram. 80 times 40 is 3,200. And then we're going to use our same bolus dose strength. Remember that was 1,000 units per milliliter. And we're going to get 3.2 milliliters, which is exactly what? Half of 6.4, right? So that's exactly what we were looking for, is half of that, which makes sense. It's what it should be. What about the new infusion rate? So our initial infusion rate was 18 units per kilogram per hour. Our new infusion rate is we need to increase that by 2 units per kilogram per hour. So 18 plus 2 is 20 units per kilogram hour. So same patient, same weight, new infusion. And this time we're going to get 1,600 units per hour. And then I'm going to make my conversion. I don't want units. Do want milliliters. There's 25,000 units in 250 milliliters. And I'm going to get 16 milliliters per hour. The thing that where people go wrong, although this would have worked out closely, is they'll take the, oh, I'm increasing by 2 units per hour, so that'll go from 14.4 milliliters to 16.4 milliliters. You'd be close, but you'd be wrong, because it's not going to be 2 milliliters per hour. It was 2 units per kilogram per hour, which is why you got to convert 18 to 20, and you have to redo the math as far as that's concerned. But again, like I said, I gave you 4 questions there. On your actual test, it'll be 1 question, but you'll have to answer 2, the bolus and then the infusion. And it's either going to be parts A and B, which is most likely what it'll be, or it'll be parts C1, C2, which is less likely to be the case. And the only thing that can really change for this is the patient's weight, right? So that's usually how I create different scenarios for this, and even what's most likely done on your actual test is you'll have the patient a different weight, but the same protocol. The protocol doesn't change. Excuse me. All right. I know that takes forever, but I'm glad we made it through. One other thing I wanted to show you guys, just because you might see this next semester, I don't think you're going to see it this semester, is a let me just see if I can get let me do this. There we go. All right. Sorry about that. I don't know if I can move this up. Let's see. Oh, I can. Sorry. There's a reason I'm doing all this, I promise you. Okay. I forgot that this was an image and I can just shift it. So one of the things that you could potentially see next semester is this new type of reconstitution problem. It's not necessarily new in that it's just that it's new to you because you don't really get to see it for for the Allegheny campus. It's usually something that's reserved for, or usually boy students see this. And this is what's considered a reconstitution question. And there's a couple things that are a little bit different in this. So first of all, I'll start off by saying what you're typically going to see is the order and the available, and then the question here, how many milliliters will you administer? So that's pretty standard. The thing that's also you're going to see is it'll tell you like for this particular medication that it's intramuscular. Okay. So it tells you it's liquid. All right. So that's important. And if you remember from looking at other medication level labels, like Dilantin has a label for a strength of 125 milligrams per milliliter. So, or per 5 milliliters. And so you know how many milligrams per milliliter for, so you can do your calculations. When you have this type of reconstitution, the label is going to be a little bit tricky because it's just going to say 500 milligrams. And because you know it's intramuscular, you know that doesn't make sense because it's missing the how many milliliters it is. Okay. So you have to find that by looking in the instructions or the label here on the side. You have to look over here to see what the actual concentration or the actual strength is of this particular medication so you can do your calculations. Now, something that's going to be helpful for you, especially when you get into the pediatrics, is considered your safe ranges or your safe dosage ranges. And you'll see here, it says usual adult dosage, 250 milligrams to 1 gram every 6 to 8 hours. What's my order? My order is 375 milligrams every 6 hours. So that's a safe range. It's the normal, usual adult dosage. We're assuming that this is an adult that this has been prescribed to. Obviously, we don't know that, but based off of the context of the question, I think we can assume that. The next thing is we need to look at the directions, and the directions say for intramuscular administration, you're going to add 2 milliliters of sterile water for the injection. So again, this is a powder that they're adding water to in the pharmacy, and then you're going to withdraw the liquid components out after you've shaken it well and give it to and administer it to the patient. So 2 milliliters of sterile water. You might think that that's the volume that you're looking for. It's actually not the volume you're looking for, but I just want to point out what you're seeing. The volume that's actually helpful is knowing the total volume that's powder plus liquid is actually going to be 2.2 milliliters. Again, you might think, oh, that's the number I'm looking for is the 2.2 milliliters to give me a total volume. That is not. You see that parentheses right next to it where it says 225 milligrams per milliliter? That's what you're looking for. That tells you the concentration of this particular medication once it's been mixed. And then once you know that, then you can solve the problem. So how do we solve the problem? We take the order, which was the 375. I just converted 0.375 grams to 375 milligrams over my available 225 milligrams times my quantity, 1 milliliter. I do the calculation, 375 divided by 225 gives me 1.666666666. So we're going to round our answer to 1.7 milliliters. Now, again, I don't anticipate that you're going to see this type of question this semester, but you might see it in fourth semester. I wouldn't be showing it to you if I didn't think that it was potentially going to show up, a question like this. So if you ever get on like ATI or NCLEX, or like I said, fourth semester dosage calc, and you see something and you're like, I know I'm looking for milliliters, but I don't see it on the label, you have to look in the directions to tell you how to calculate that. All right. Well, those are the things, like I said, because those are the new things. Those are the things that I wanted to focus on. All right, so good question. Will the test be on paper or online? I don't know that answer. But hopefully, when you guys have your orientation, you can ask that question so you have some idea if it's supposed to be online or in paper. I think they want to go back to being on paper, but some of your instructors may prefer the online version. I just don't know that. So. All right, so like I said, I'm done with what I wanted to review with you. So, but if you have other questions or if you want to see something again, just either let me know in the chat or just unmute and let me know. Okay, so yeah, so looks like if you've had it on paper thus far, it's probably going to continue to be on paper, but I know it depends if your day or evening and then how your instructor was setting that up. I know that might be a difference. So like I said, just ask that question at orientation. I just do the reviews. I don't know how your test is going to be specifically administered to you. And then, yeah, at 5 p.m., I'll probably go through what I did with you earlier or at the beginning of this review. I'll go through the heparin and insulin infusion calculations and then do the heparin protocol and then the reconstitution. So I will repeat that. But if there's other questions, that might be what's different for the 5 p.m. session. And again, if you can't make the other sessions, just know that you can always catch the replays on YouTube.
Can I ask a question about rounding, please?
Yeah, go ahead.
Because in the instructions in the guidelines for the practice tests, so it looks like normally if the volume or the amount is greater than 1 milliliter or I guess 1 gram, right? Or kilogram. So we would need to round up to the 10th place, right? And if
Correct.
it's less, then it should be rounded to the thousands. But for example, when we
to the
convert,
100th,
huh?
to the 100th place.
If it's less.
If it's less than 1, round to the 100th, not the 1,000.
Because I'm looking at, I'm looking at the instructions, like a 2-page handout that we had. And it says that the volumes less than 1 milliliter should be calculated to the thousands place. Oh, I'm sorry, and rounded to the nearest 100. Yeah, that's correct. But for example, like when we convert, for example, milligrams to grams, we wouldn't round in this case, right? We would just, for example, like in one of the practice questions, if we needed to convert like 1275 milligrams, we would just convert it to 1.275 grams. Like in this case, we wouldn't have to round to 1.3 grams, correct?
Correct. Yeah.
Okay.
When you do basic metric to metric conversions, you don't round those. Okay. You will round if you go like metric to household. So like if you go from pounds to kilograms, so that's household to metric system, you would round to the nearest 10th in that example. But if you're going from grams to milligrams, micrograms to milligrams, or milligrams to micrograms, milliliters to liters, you do not round those numbers.
Right. So like don't worry basically about rounding for the conversions, but
for metric to metric conversions, because you will round if you're going to household to metric or metric
Okay.
to household.
Mhm.
Yeah.
Okay.
And I'm just adding this little highlight here. Okay, good question, by the way. Yeah, rounding is always one of those weird things that creeps up on you, and you're like, "Ah, why did I miss that?" Because it's because of the metric to metric. You don't round because you're just doing conversions. You always want to do your rounding at the end of a math problem, if you are going to do rounding. And then when it comes to, like, if you're doing drop rate, remember, you can't give somebody a partial drop. They get a whole drop. So you always round to the nearest whole drop. So if you get like 67.1 drops, it's 67 drops. If you get 64.9 drops, it's 65 drops. Just round to the nearest whole drop.
Can we do a drop rate question real quick?
Yeah. I didn't do those just because I knew you've already done those. You did those last semesters. So I was like, okay, you're probably pretty good with those. But I appreciate you saying, please, let's do it.
Practice, practice, practice.
Mm-hmm. Okay, here we go. All right. So your drop rate questions. All right, this will be a good one to do. All right. So here, I'm going to change this up a little bit. So let's make this 125 milligrams. Let's make this 375 milliliters over 1 hour. Actually, I'm sorry. Let's do that over 3 hours. And we'll make our drop factor this time 20. So I'm trying to give you some different factors. All right, so as a reminder, in order to calculate flow rate or drop rate, I need two pieces of information. I need flow rate, which is typically in milliliters per hour, but it could also be in milliliters per minute. So it just depends. Okay. And I need my drop factor. At Allegheny County, I could tell you that it's always going to be, or at Allegheny campus, I could tell you it's always going to be given to you. May not always be 20, which is why I'm erasing that. Okay. So sometimes it's 20, 10, 15. There's a variety of things to view, but both of those things will give you your drop rate, which is drops per minute. So the one thing you might have to do is convert hours to minute, and you're going to have to do that for this one here. So what we're going to do is we're going to take our flow rate, which is 375 milliliters over 3 hours, multiply by my drop factor. Now, before I go to the next step, I'm not done because I need to convert hours to minutes. So one final step is I need to divide by 60 minutes. So I'm going to take 375 times 20 divided by 60 divided by 3. And I'm going to get 41.7. But because this is a drop, 42 drops per minute. And then I think I've shown this shortcut to you guys before in the past. But another way is instead of doing 3 hours, just convert 3 hours to minutes. So 3 times 60 gives you 180 minutes. So another way you could write the same problem is 375 over 180 minutes times your drop factor. And then now you don't have to do any other steps. You can just get right to your answer. It's already in per minute. Yeah, and like you were saying, practice, practice, practice. It's always a good idea to, like you said, practice, 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 because it's been a little while since you've seen some of these things. So it's a good idea to go back to and review and to just take it fresh. Even if the question looks easy and you know how to do it from scratch, or you can just do it in your head, write it out. Make yourself go through the steps just to make sure you have it down. I've gone through all these multiple times. So there's different ways that they've been explained probably over the years. I would not encourage you to go back and watch all the old like full length review sessions just because, you know, they're long. Just stick with the newer ones that will be uploaded, like I said, either later today or tomorrow. All right. Well, like I said, oh, go ahead.
Oh, no, I was just gonna say, you're gonna be back at 5 today, right?
Correct. That's what I was just getting ready to say. Yeah, I'm going to be back at 5 for you guys for 2:20, 2:30, and then on Thursday at 1:15 and at 5 as well. So if you have any other questions, or if you can't make it, just email me and I'll try and answer your question via while I'm on here, and then you can just catch the replay. All right. Well, if any of you are coming at 5, I'll see you then. If not, good luck on your test. If I don't see you on Thursday. And again, if you have any questions, you can email me and I'll put my email here in the chat just in case if you don't have it.
And is Thursday going to be the same as today or other problems, or depends on what people need?
Right. It always depends. So if I have everyone asking me to do like you know, other types of problems, then that's what we'll focus on. But I'll predominantly start with just doing like I did today, the insulin and heparin infusions, then the heparin bolus, weight-based bolus protocol, and then if there's any other questions. Oh, and then the reconstitution question. All right. Well, I will talk to you guys on either later today or Thursday.
Thank you.
You're welcome.
Thank you.
Thank you.